Okay, geometry, let's try this again. Just had a little camera mishap, but hopefully it's working now. Just got two more examples to demonstrate with you guys on this basic SOH-CAH-TOA. SOH-CAH-TOA stuff. So let's try to use this as an application with some of the other things that we've been learning in chapter. Now, we've done some Pythagorean theorem type problems. What about the special right triangles that we just recently learned about? So let's say we have a 45, 45, 90 triangle. 45, 45, 90. And it just says, hey, what's the sine of a 45-degree angle? What's the sine of a 45-degree angle? Well, without using a calculator or something like that, it'll spit out some sort of a decimal for you. But we just want the ratio that if you took a 45 here, or you can use the other one, opposite is A. This one's also A, and this one's A root 2. Doesn't matter what number you fill in, the ratio for it is still going to be opposite A over the hypotenuse, A root 2. The only thing is you can't leave it as A. Whatever number we've put in, like 8, 8, and 8, they would still cancel 8 and 8, or 10, 10, and 10 root 2. The 10s would cancel. So this would give me a 1 over the square root of 2. We can't leave a square root of 2 on the bottom. So we do this and rationalize the denominator. And the sine of 45 degrees is the square root of 2 over 2. What if I ask you what's the cosine of 45? Well, shoot, that's not going to change anything. Adjacent is A, hypotenuse is A root 2. So if I go A over A root 2, dot, 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 I'm going to do the same thing. I'm going to get square root of 2 over 2. Well, that one's kind of easy. But what if I was asked, what's the tangent of a 45-degree angle? Let's say we're still talking about this one. It wouldn't change our answers if we were talking about the other one. What's the tangent of 45 degrees? Remember, you got to go opposite over adjacent. Well, across is A, and adjacent's A. Wait a second. Well, it doesn't matter what number you fill in. It's going to be the same number top, same number bottom. It's going to equal 1. It's going to equal 1 every single time. Every single time. All right, so they can do that with 45, 45, 90. They could ask you what's the sine of 30, 60, 90. All right, I think your homework would do that. 30, 60, 90. This is A. This is 2A. This is A root 3. So the sine would be the opposite over the hypotenuse, sine of 30. Sine of 60 would be A root 3 over 2A. The A's would cancel out. So those kind of questions would also show up. All right, I got one more tricky kind of problem that shows up. I'm going to give you one that shows up in the homework, this style. Last one. If the cosine of angle A is equal to, well, let me think about this, is equal to 8 over 17, then the sine of angle A equals what? And the tangent of angle B equals what? Now, I should probably draw some sort of a triangle for this A and B. Looks something like this. Make this A, this B, this C. All right, so all of this would be given, and they would ask these two questions. And so the only thing we know is that the cosine of angle A is 8 over 17. So knowing that that's opposite, no, I'm sorry, it's cosine. It's adjacent over hypotenuse. Here's angle A. Adjacent is the 8. Hypotenuse is 17. Oh, it's a common right triangle. 8, 15, 17. Now I can answer all these questions. What's the sine of angle A? Opposite is 15. Hypotenuse is 17. 15 over 17. What's the tangent of angle B? Now they're talking about the other angle. That would be opposite over adjacent. Tangent of angle B would be 8 over 15. All right, that's all my examples. We'll be doing probably a homework assignment, page 421 out of the book. We'll do something out of there, I think. But you need to know your patterns of the Pythagorean triples. It would really make this homework go a lot easier, 8, 15, 17 being one of them. And you got to know your patterns for the 45, 45, 90 triangle and the 30, 60, 90 triangle. A, 2A, A root 3, A root 2. You got to remember those patterns and how they work, and it'll make a lot of what we're doing in the trigonometry a lot easier. Trigonometry likes to use those common right triangles a lot. Okay, that's it for video number 2.